So in the last lecture, I gave you guys an introduction to the dot product. Today I'm going to jump straight in and do some examples. So question 1, say you're given dot product A denoted by -4 and -1 and another vector B denoted by 0 and 2, and I asked you to get the dot product between A and B. How would you go about doing this? You could pause it and then try and calculate it yourself. If not, we'll go through it. So you take the first components, so -4 multiplied by 0 plus, and then you take your second components, -1 times by 2, and you'll get 0 minus 2 is equal to -2. And that's the answer for this question here. What you'll note is that this -2 is just a scalar, right? It's not a vector. It doesn't have a direction. It's not, split into components. It's just a number. It's just a scalar. Very important to take note of that. Question 2 is if you were given vector A as -5 and +5, vector B as -3 and +3, and vector C as -5 and +6. And I told you to go ahead and calculate A times B plus C. Again, you could pause here and do it yourself. The way I would do this is first of all to take note of these two things here, right? So you should be dealing with what's in here first before you even worry about the dot product, right? So let's go back so we can see. I personally like to keep the A by itself, especially if I know I'm not going to be working with it until 2 or 3 steps later. So what I'd do is I would say A multiplied by, and then I would add these two here. So B plus C, well, we have -3 minus 5. I'm doing this, right? -3 minus 5 is -8. And then we have 3 plus 6 is 9, right? Then, once we've solved whatever's in the brackets, I'll then introduce my A. So your A is your -5 multiplied by -8 and 9. And this becomes really straightforward. It's really simple. Your dot product operation, you're going to multiply the first two by each other, and you're going to multiply the second two by each other, and you're going to end up getting -5 times -8 is +40, and you're going to add 5 times 9 should be 45, and you end up with 85, and that's your answer. Question 3, it's quite similar to question 2. So say you're given -4 and 5, and then B is obviously -6 and 7, and C is given by -2 and 8. And I told you to calculate A minus B dotted with C. Again, first of all, you're going to focus on what's in here, right? So A minus B. And if you guys forgot how to do that operation, if you have, let's say, vector A denoted by A1, A2, and you have B denoted by B1, B2, and you wanted to subtract them, you would say A1 minus B1, comma, A2 minus B2. So that's a bit of a recap for what we did in lecture 1. The subtraction is a bit more trickier than the addition. That's why I wanted to do this one as well. So again, pause it here, give it a go, and then come back when you've done it. Let's do it in blue. So A minus B, you're going to say -4 minus 6, right? So -4 minus -6. And then your second component, your 5 minus your 7, right? 5 minus 7 dotted with C. Now, instead of writing C, you could just, sub this in. I prefer not to. It saves me time. It saves me space just writing it right at the end. So anyways, from this, we'd go and say, well, -4 minus -6. Well, 2 minuses here just cancel out. And this becomes a plus. So -4 plus 6 is +2. 5 minus 7 is -2. And now you can sub in your C, which is -2 and 8. And then obviously to do the dot product from here, you'd be taking this, multiplying it with this, and then you would be taking this here, multiplying it with 8 over here, and then adding them together. So 2 times -2 is -4, plus minus 2 times 8 is -16, and you end up with -20, and that is your final answer. Now for question number 4, you're given vector A is equal to 4, 2, and vector B is denoted by 1, 1. What is the angle between vector A and vector B? So I did show you guys how to calculate this in the lecture 2 video on the dot product. If you haven't seen it, go and watch that before this. So the formula to calculate that is you take your angle theta is equal to the inverse of cos, so cos -1 multiplied by the dot product of A times B divided by the magnitude of A times by the magnitude of B. And once you basically get these three things here, so number 1, number 2, number 3, you just sub it in into your calculator, and then you should get your angle, right? So the first step is to realize that you don't have any of these things, but you have enough information over here to calculate it. So first of all, the dot product between A and B, it's going to be 4 times 1, which is just 4, plus 2 times 1, which is just 2, is equal to 6, right? So we already have that this over here is equal to 6. Secondly, the magnitude of A, it's going to be the square root of 4 square plus 2 square, and that's going to give you 4 square plus 2 square, 2 times by the square root of 5, right? So 2 square root of 5. And then to get the magnitude of B is 1 and 1. We'll do B here. 1 square plus 1 square on the square root is still equal to 1, right? And we have then this over here. Okay, you guys can go ahead and calculate that in your own time. I just have one more example to do. So say you're given, I see this in white, number 5. If I tell you 2a plus 4b is equal to 34.38, and I want to know what is a1 and a2, and I give you that b is equal to 8, 5, right? So it's your b1, so here is your b2, b1, right? So firstly, you would sub in this here, okay? So you'd be left at 2a plus 4, 8, 5 is equal to 34, 38. Step number 1. Step number 2, multiply out the scalar over here, in here, and in there. So 2a plus 4 times 8 is 32. 4 times 5 is 20, is equal to 34, 38. You would then take this over here and bring it that side, right? So you'd be left with 2a is equal to 34, 38 minus 32, 20, and then say 2a is equal to 34 minus 32 would be 2, and then 38 minus 20 is 18, right? And then we're not quite done yet because there's a 2 that we need to get rid of. So you'd multiply this by 2, divide this by 2, divide this by 2, and you'd be left up with a is equal to 1, 9. And that is how you calculate a if you're not given it but you're given what b is. So all you need to do is know how to perform a scalar operation, as we did with the 4 over here, know how to subtract the vectors, a from b, and yeah,